Hello, good morning. Can you see me? Can you hear me? Can you see me? Can you hear me? Can somebody let me know if you can see or hear me?
Yeah, we can hear you. Yeah, we could hear you.
Okay, perfect. Wonderful. Are we ready? Are we ready for another session? How are you guys doing?
Good.
Good? Okay, I'm watching chat as well. So if you ask anything there, I'll try to answer. Okay, so can you see my shared screen as well? Can you see my shared screen as well?
Yeah, we can.
Okay, good. Okay, so busy day for me today. I have lots of nice things I want to talk to you about and answer all your questions and so on. So, okay, so we will get started in a minute. Almost time. Yeah, it is time. So we should start slowly. Okay, so if you can follow with me, I want to go to session 2 on the website, and we'll click on this thing called review session 1. So we'll spend a few minutes quickly just reviewing session 1, and then we can start on some of the new ideas I have for session 2. So just to get started, warmed up, let's do a quick poll. How much time did you spend working on Python since last Sunday's class? So can we all click on this poll? I was not able to log into the website, so I was not able to submit. Okay, no problem. No problem. Still cannot log in. Um, so for those who could not log into the Trinket site, just click on the link, create a new account, and set up a password, and then try to go to the course page. If there's problems, just send us an email, okay? And then we will sort it out. Okay, so let me see. I actually spent more than 3 hours reading some of your submissions and answering some of your questions and so on. So let's see. Okay, half and half. Okay, 8 of you have replied. So I guess not all of you have replied to this one. So I'll refresh this in 1 second. Uh, okay. So let's. So what do I want it? What do I have planned for today? So of course I have planned for today is to continue. Okay, some of you have spent more than 3 hours. That's excellent. Okay, and the most important thing is rather than spending 3 hours or 5 hours in one big effort, it's better to spend a little time every day, right? So break the 3 hours into, I don't know, 4 or 5 sessions maybe, and do half an hour every day. Okay, and I make sure that there's plenty of small projects for you to work. There are things that I've given you, but slowly I want all of you to develop the skill of making your own questions and your own projects. Okay. Okay. So what do I want to do? Quickly, just review what we learned last time, and maybe even do one or two of the projects, depending on your feedback. Okay. Quickly, what about this poll? Did you complete and submit any projects from the Trinket side? So some of you couldn't log in, so don't worry. But for the rest of you, 6 of you submitted. Okay, those who didn't submit did not say no. Nobody said no. Okay, well, okay. So at least some of you. I have actually seen all your work, so many of you have submitted, and that's really excellent, right? So please keep on, working on it. If there's any comments or feedback, do share them with me. Okay. So now, which puzzle should we solve together now? So I guess this is something we can think of together. So which puzzle would you like to solve? I'm going to give a minute and I'm going to, okay, let's see what comes back here. I'm just going to say view results because I'm not 40. You count on your fingers. Okay, counting on your fingers is a little difficult. I have added it into the discussion for today. And the COVID celebration, some of you wanted to look at that. Okay, so Only 2 people have responded. So, okay, probably half and half. Okay, so now let's see. More of you respond quickly so I can just see which ones we should work on. Okay. Uh, so that's on the next tab. Okay. Most of you want to understand this. Okay, so can you tell me on chat quickly, did anyone solve this problem by playing with your fingers or something if you didn't write code even? Was there any quick solution you
Yeah.
had? Okay, some of you are on chat, so anyone was able to solve it? I needed help. Okay,
Yeah.
it's little bit hard. Okay, so don't worry. Sometimes there will be things that are a little hard. We'll just spend some time thinking about it. Okay, and then we can solve them together. Okay, so counting on your fingers, I promise to spend some time on it. We'll move it a little later in the class. Let's try this COVID celebration together. So for those who haven't been to the website, I guess it looks like this. If you, sorry, I have to go. So when you log into the Trinket site, it kind of looks like this. And if you go here and you say if you say home, it will bring you to this page, and then all the courses are there. And for me, there are a lot of courses. For you, there should probably be only one. So you can just find our course, and it's Python Bootcamp, right? So we can just go to our course, and here is all the projects, okay? And I've added new ones for session 2. And here is the one about post-COVID celebration. Okay, so then you just click on show trinket. You see, I can see who has submitted, etc. So I tried to catch up with all your work, but I haven't got back to everybody. Okay, so we'll try to catch up today and get everyone replied to. I do try to reply to all your code with suggestions and comments and questions even. So if you've submitted, don't say, oh, I'm done, it's done. There might be something from me. So please go in and check, okay? And then the second thing is when you submit something, take a minute and write 1 or 2 lines about your own experience. Was it interesting? Was it fun? Was it challenging? Something about how you felt doing it, okay? Because that is very important to me. Right? I'm not just giving you homework that I'm just going to put a grade on it. I'm really trying to see if it's keeping you engaged and showing you new things. Okay, with all that said, so how shall we go about this? Right? So we want to know. So one of the things with what we did is this idea that we can use Python as a calculator, and that's going to take care of all the multiplication and division, make it easy for us. So we can focus our mind on asking important questions. And for the important questions, we want to get some sense of the world around us. So for example, here, I would like to know what is the population of US, right? And here I'm going to show all of you, okay, it's too small right now, so let me make it bigger. I'm going to show, yes, thank you for saying in chat, population of the US. So usually we want to look at this, and even we want to make it super precise. But what I want all of us to have is a sense of what it shall be. And the first thing we would say is it one, like for example, is it 1 million? And the answer is probably no. So is it 10 million? That seems like some small part of the US. So probably 100 million we could get to. And the first thing I want all of you to do is to think of millions in terms of exponents, right? So 100 million would be, let's write 100. And the nice thing about exponents is instead of saying million, I just put 6, right? So just like we speak in English, you say 100 million, I put 10 star star 6. So all of us can get used to quickly writing these big numbers. And some of you have given that feedback in your code submissions, right? So a lot of you put a lot of zeros, and sometimes you can miss a zero. Yes, somebody asked about the Usain Bolt. I'm planning to do that. We're going to do it together, okay?
I
Yes.
have a quick question though. You
Sure.
said 100 to the 6th power. When, if you look on top, you said you can use the population of United States
Yes.
at 300 million.
Correct. I'm getting there, right? So, yeah. So what I was trying to show you is by just thinking about it without looking at Google, you can start to get towards the answer, right? Now, I've already been kind and given you a clue, right? So I got to 100 million just by thinking about it. This 3 is little difficult, right? 200, 300, 400. It's very hard to know just by thinking, is it 300 or 400? For that, you need some experience. So what I want all of us to develop is, if it's something strange that we've not seen before, we should still get to 100 million somehow by just thinking, okay? And after that, it's, so you can play with this later. So let's make it 300, since I gave you, since I gave you the clue already from the solution problem. So you use 300. And if you really want to double check, you can go to Google and get the exact number and so on.
Excuse me?
Yeah?
The exact number is 382 million.
So interesting, right? It's getting slowly towards 400. So it's very useful here. I'm trying to show you the difference, that sometimes, especially in physics, where we're trying to calculate things, it's okay to use approximate things because we want to get a sense of the answer. I don't need to know exactly how, because later I'm going to do square feet and so on. You're going to see it doesn't matter whether I put 380 or 370, or 400, right? So we can tweak it. That is the next stage. So the first stage is to get into the ballpark. And what we're going to find with this exercise is, when we think about 300 million people all coming together, we think that, oh, we need half of US or something. We need a lot of space, right? And what we're going to find out is we don't need that much space. But let's see, right? So first thing is I start with 300. Then I ask, how much space does a person need? Space per person. So how much space do we think of one person needs? If you're standing like in a school assembly or in a concert or something, we're standing side by side, how much space would a person need? Somebody's going to tell me. You can just unmute your microphone and tell.
1 square.
1 meter square. I
Yeah?
took 5 meters square just to be safe,
5? Okay.
Yeah.
Yeah. 5 meters is a lot of space, right? So, yeah.
Yeah,
So,
but it's like people can easily move around.
yeah. 5 meters
I would-
already is
I would say 2 meters.
Yes. 5 meters.
1
Yeah?
square foot.
How much square foot?
1.
1 square foot. So, okay, we can play with this, right? But I just want to make a comment for us to think about. Right now, when we do social distancing and we say when people go out, they should keep a distance between each other. How much distance do we ask them to keep? Do you know?
6 feet.
6 feet. So you see, if it's 6 feet and you make a box or which is 6 feet by yeah.
But actually, you at above you said, let us imagine that we are past the COVID crisis,
Yes.
which means you don't really have to social distance anymore.
Correct. Beautiful. Well done. Well said. But I'm not putting the number yet. I'm just having a discussion with all of you. I'm saying that even if it was COVID and we wanted to keep social distancing, then how much would we have put? We would have put 36 square feet, right? Because 6 square feet by 6 square feet is a box. And we said each person, so we have to spend some time. It's not, the answer is not correct, 36. Maybe you can do it as a small project and calculate what we need. Okay, but you need something like this. Because if you make a box of size 36 and I stand in the middle, will it work? I think it will work. Okay, so this is the biggest size we would need. Surely this is post-COVID, so I don't need all this. So we can go to something smaller. So maybe, I don't know, I was thinking of like 3 square feet. Is it okay if I use this? 3, some people said 4 in chat. Okay, so let's use 3 or 4. Let's do 4, okay? It really doesn't matter. You can come back and change this. And I like to always think of units, okay? So 4 square feet. So now how much space will we need? Total space. So total space will be population of US.
Won't that be too less? Like 2 feet by 2 feet? 4
Yeah,
feet,
how-
4
how-
square feet.
Yeah, it's kind of squeezed in, right? Okay,
Yeah.
so you know times.
So maybe like
maybe we can do 3 feet.
maybe
by
like 16.
3 feet. No,
Six.
how wide are your shoulders?
I think.
Okay, first
feet?
let's ask.
I
Sorry,
don't know.
sorry to interrupt. What were you saying?
I think a feet or something. 1 feet maybe.
Let's be generous and say 2, right? Okay, first I have to ask you a question. Which is the widest part of our body?
I think the chest part because I think the chest part.
Shoulders?
I think what?
This like the shoulder to the
The
shoulder.
shoulders, right? Yeah, maybe hips are competing, but shoulders and hips will give us some idea, right? So you can do all this. Okay, somebody talked about SI system. So here's something I want to tell. Generally, I would say SI system is probably the easiest and cleanest. But what I want to teach all of you is these different systems exist for historical reasons. and we should make it easy for ourselves to switch between them if we want to. Okay, it's just a question of finding a number. And unfortunately, the world we live in, especially if you travel and read articles by other people, then they will write in whichever system they like to use. Particularly in America, if any distances are measured, they'll always say in miles. And in England or in India, they will always say in kilometers, right? And we can sit there and say, oh my God, I cannot think in miles. But actually, the difference between kilometers and miles, I learned this when I was very young, is just 1.6, right? 1.6 kilometers is a mile, right? Something like this. So you can have a simple conversion. And once you do the conversion, you will find lots of things you can think of in those units. For example, since we're going to talk about Usain Bolt later, a very famous person called Roger Bannister, we thought at some point that people could not run a mile in less than 4 minutes, right? A mile is 1.6 kilometers. So I'm saying that was called the mile barrier, right? And Roger Bannister broke the mile barrier. He went under 4 minutes. Very interesting topic. If you're interested, let me know. We can talk about it more. But why did I mention Roger Bannister and the mile? I said because now you have to know the mile. And in fact, even many races today are still run in miles, right? So let us all learn how to switch back and forth, okay? And just going from miles to kilometers, just multiplying by 1.6. And many places, for example, if those are interested in long distance running, if you run a marathon, everybody knows it's about 26 miles. Nobody knows what's the kilometers for it. So we can't always force the SI system onto people, right? So we become flexible and we just learn a couple of these things and it'll be easy. And you don't have to memorize it. You can always go look it up. So you always work in whichever units you want, and then you can just flip it at the end, okay? So right now I put 9 square feet. We can switch this to meters in a minute, okay? So, okay, space per person. So we put this here, and now we want, so I want to show all of you that we're going to use all this like this, right? So we say print, and then we'll say total space. So many of you have done this kind of work, right? You've done this and you submitted this. Okay, so we'll see something. And I've come back to you and said, come on, that's such a big number. How will I understand even this, right? First of all, I'd count all the zeros and so on. So it would be nice to convert whenever we see numbers that are not obvious to us. There must be some other natural unit present. That is a clue for us. Some natural way of thinking about the number makes it easy for us to understand. So what is the unit of this number? What is this number actually?
Feet square.
Feet squared, right? Yeah. So feet squared is obviously not good. If I'm talking about one person or how much space is one room, in fact, a lot of rooms are measured in square feet. Even houses are measured in square feet. So for example, if you buy a house in the US, they'll say 1,000 square feet, 3,000 square feet. You can think about your own house and say how many square feet, right? It's natural because it's a small number. It's like 1,000, 2,000, 3,000. The moment we get to billion, million square feet, it's not a good unit anymore. So what would be the new unit we want to use here? So you should think it's square feet. So it's some kind of square.
Mile.
Square miles, right? Yeah, that would be interesting. So now this is something we need to know. It's not easy for us to know this answer. So what do you think? How do we convert square feet to square miles? Can I give one of you who has the computer, can you look it up and tell me? How many
I think it's 128 feet per mile.
Yes, but do the square miles now. Okay, and in fact, I want to give this as a kind of thing for you to do slowly, okay? Because here, so you're going to divide this by something, and then the answer will be in square miles. So what is it? 5,280, somebody says. Okay, that's good. Well done. Thank you. That's Shaurya. Thank you, Shaurya. Okay, 5,280. So let's see what happens. Okay, we got something. Is that correct? What is 5,280? So somebody said 5,200. What is 5,280?
It's only in the length, so we should actually, I think, multiply it like 5,280 into 5,280.
Yes, and I'm going to
in square miles.
Yeah, so I will, instead of multiplying twice, I will use powers. Okay, I will do this. Okay, so now we got something that's interesting, right? First of all, notice it's 96 square miles. Okay, so we got a number. Now let's try to understand this number. What do we know that might be 96 square miles? Something, some city, some town. Does somebody want to look up? Let's look up a city. Pick New York City, for example. How big is New York City? This one you can Google because we probably don't have a feeling for the size of cities. But how big is New York City? 800 square feet? 800 square miles, sorry. Somebody says 800 square miles. Yeah, 800 square miles. So you can pick your favorite city, but what's surprising that I can put the whole of US population into that space. Was that something we expected? What do you think? Anyone, you can unmute and tell me. Did we expect it would be small?
No, I actually thought it would be like a lot bigger.
Yeah.
And it's actually a pretty small number.
Yeah, it's pretty small, right? Only one of you had an interesting idea of making the people lie down on the ground and stacking them head to head. That would make a very long stack of people. I didn't even calculate if we stack them one on top of the other, how big that would be, okay? But if they stand side by side, it's surprisingly small. Okay, so there are a lot of interesting questions we can ask. In this same spirit, you can change this quickly. This is something, so I'm also showing you, try the density of India. Yeah, you can do this. So this is all things to do, right? So go to India and you want to repeat this, just replace with India's population. And actually it's kind of, let me just do it here. You will put India's population is what? It's about 1.5 billion. It's not yet 2 billion. Okay, so I have to do this and I have to put this.
1.2.
1 point what?
2.
1.2. I put 1.5. Okay, good. So I know it's more than a billion, right? So that's another number to have in the back of our mind. It's a very big number, 1 billion. Okay. And then we can just repeat this calculation and you get 300, maybe 400 square miles. But that's still not that big, isn't it? So compare with an Indian city, go and look at the size of Bombay or Delhi or something, and just try to think about how big is this space, right? Something for us to play with and understand, okay? Again, you see, at least I'm surprised how small this number is. Then I usually, when I'm surprised like that, when you get a number that's too big or too small, you go back and double check and triple check your calculation. Maybe even you talk to someone about it. Hey, I'm getting this number, just make sure it's correct. Okay, I missed something, or instead of 9 here, I put 8 or 10 or 12 or some small mistake. So you see, we got this. Now I'll show you how this can lead to all kinds of interesting questions, right? It seemed like a funny question to put all the people side by side. But for example, we can ask, hey, we want to build a new modern society where everybody has a space to live, right? So we want to give everybody, yeah?
How to get the answer till 2 decimal points?
Ah, that's a good question. Okay, so that is something we're going to, okay, I'll do it now, but yes.
I think we can use the float function because in Java we have two different functions called, two different types of real numbers, which is float and double. And if you use double, it is in default, it is double, so it displays a large number. But if maybe we use float, then it can display a smaller number.
Okay, so 1 second. So sorry. So if you use float, what did you say about float?
So float displays a smaller value because not up to large level of precision. So is there any specific type in Python also?
Yeah. So what I'm saying is, it's very interesting problem. We'll talk about types in a sec. Let's do it right now, okay? So I'm going to just comment out this. It's important for us to understand this idea. So the idea is this: if I make a variable, let's call it x, and we put an integer in it. Let's put the integer 3 in it. Now you can ask Python, what is this? Is it an integer or is it a float or whatever? So there's a nice function to check it. You say type, and then you say x. So then I run this, and it says that it's integer. Do you see? Everyone sees that it's of type integer. Now notice that if I do 1 by 3 here, right? When I do 1 by 3, 1 by 3 is what? It's 0.333. It cannot be an integer anymore, right? So when I do it, it automatically calculates the answer and it changes its type to float. So you can see in our calculation here, when we did this calculation, total space divided by this number was actually automatically a float, right? And so we cannot do anything else. It is automatically a float. But what we can do is say, show me some number of digits. So here, there's a thing called math. Okay, I don't want to open this Pandora's box, but you can say import math as M. I like to do it. Just see it later. We'll come to this in more detail. Okay, and here you can do M dot round, and then you can just print out up to some number of decimal places. Okay, so let's do M dot round 2, and I'll take off this type thing because I don't need type anymore. I want to see the actual value, and we will play with this round thing and see if we can get it to do what we want. So M dot round, and now let's see what happens. Oops. Okay, so let's do something here. Let's do another function. I don't remember now all of them, but let's do this. M dot floor. Should be floor at least. And I don't need to. So we'll play with round next time, okay? I didn't plan for us to play with it. Oh, oops. Yeah, so 1 by 3 is, so let's do 10 by 3. And now it will get rid of all the decimals. You see, it gives me 3. So let's use floor if you want to go to the lower side, and you can use ceiling to go to the higher side. So let's go back to our question here and just put that in if you want. Round will allow me to control how many decimal places.
Excuse me, so you remember how you just did M dot floor to get rid of all the decimals?
Yes.
So isn't there another way to do that, just to say int and then?
Just to say what?
Just to write int.
Yes, that's another way to do. Okay, so that's even faster. So let's try that. So you say, okay, this is a float. Just make it back into an int. Right, so let's try that one. So if you do, just make it into an int, it will get rid of all the decimals. You get 387 square meters. So maybe why don't we take that as a solution for this next couple of sessions, and then we'll spend some time.
So wait, does this approximate the value? Like the int function?
Okay, beautiful. That's a good question. And I'm saying that in programming, we always going to test it out. Okay, so let's test it. How will I test it? Let me just test it quickly. So I'll say int, and I'll say 3.1, and I'll say print int 3.9, and just see what does it do. Okay, so now we know the answer. It's not rounding, it's just simply cutting it off. Okay, so somebody
so what does the floor function do? Like
floor
it does the same?
does the same thing. It cuts it down to the floor.
Okay.
So if floor cuts down and seal cuts up. Right?
So for both of these functions, do you have to like put the import math as M?
No, for floor and seal, yes, because they are inside the math library.
Okay.
So let's use int for now. Okay, next time at some moment we'll explore the math library. Okay, and I don't want all of you to get lost inside rounding and all these details, right? So let's keep it simple and pretend we don't need to round. If you want to cut off things, let's just use int and cut it off, because we are just basically saying decimals are not important. Okay, and next time we'll spend some time doing some math. We'll get into rounding and do some more complicated things. Okay, and use more functions. We'll do square roots and all that stuff. But in the meantime, if you need a round, you feel you need it desperately, send me a note, okay? And then I'll tell you. Or in one of your submissions, you can put the answer. Is that okay?
Yeah.
Okay. So, because rounding is a whole story that we don't need to get into right now. Okay. So we did this. Now I think we want to go. So this was the problem we wanted to do. We learned something. I just want to finish this by saying, why do we do problems like this? I want to give you an example of something we could do, which is interesting. Suppose we say we want to build a new society. And in this new society, we want to give everybody a small house or a small plot of land. And so we decide to give everyone, I don't know, you pick a size here, right? So then you say you want to give everyone a small piece of land, say, I don't know, half an acre. See, no, new units now. We don't measure land in square feet anymore, okay? But you can pick your favorite units and then ask how much land do we need to fit the whole population of the world or the population of India. I would be very curious what you come back with. Right? Because we have situations like in New York City or India where people are just squashed on top of each other. They live in, in ghettos and slums, and they barely have, 100 square feet per person for family, right? So we can ask the question, is the earth capable of sustaining? By the way, one of the surprising things you will know when you start thinking about the earth is the population has really grown a lot. And the earth's population is about 6 billion people. It's very big, okay? Anyway, lots of interesting questions follow. And that's what I wanted to share with all of you. That when we start exploring this, it can lead to all kinds of interesting follow-up things and ideas. And some of you have even shared your ideas with me, okay? So let's go back now. And somebody had asked about Usain Bolt. So I think we'll go to that one next, okay? So actually, I put this Usain Bolt question because I started to ask this question for myself. How fast can a human being run? Right? I mean, and then I said, okay, the place where we measure the speed of human beings is usually the 100 meters race. Obviously, people run longer races, but if you have to sustain speed for a long time, human beings actually slow down. By the way, that's a whole nother discussion. Another time, if you're interested, let me know. We can talk about human endurance runners. It is really amazing that humans actually are one of the best. The humans are not necessarily the fastest creatures on the planet, right? There are things that can outrace the human easily, animals. But in terms of distance, humans are probably the top. We can, because we have very advanced ways of storing energy in fat. We have sweat glands that can cool the body, etc. And we can, for example, a horse, if you take a horse and you ride it fast for a long time, it will overheat and you have to stop the horse. You'll hurt it otherwise, right? So humans have tremendous endurance capacity. Anyway, so that's a separate discussion, right? What happens when we go to the distance side? Here we're just talking about raw speed. So better keep the distance short and try to go as fast as you can. Now, do you think we can go faster if we make the distance, like instead of 100 meters, we make it 10 meters? Do you think we can go faster?
No, I think we actually need something to boost us up.
Yeah.
And I think in the middle, we might be going the fastest.
Correct, correct. So we need some distance to get accelerated, right? We're not shot out of a cannon. We start from stationary. We need some time to speed up. So it's again an interesting question, right? What is the best race so we can get to maximum speed? But anyway, that we won't get into as well. Okay, so now the point which I thought was interesting is when you look at problems like this, it's nice to have a simple model that explains what is going on. And so what is the simple model that can explain this? Well, the speed depends on, oops, what did we do? The speed depends on two parameters. It depends on your stride length, which is how big is one of your steps, and how many steps you can take in a second. That's it. I don't need to know much more. And if I know how big one step is and how many steps you take per second, then I know how long it will take for you to cover some distance. The distance is already fixed, so I can convert it into speed. Okay, and you should work out this thing, play with this a little bit more, right? So then the question becomes an interesting, tricky question. I can look at 100 meters races. I can pick one of the faster people like Usain Bolt. But then how do I get hold of the stride length? How do I know how big his stride is? I can't go and find Usain Bolt and measure him, right? What do we do? Right, now we can guess, or I'm going to propose we go and look at this video. So I want all of you to watch this video with me, and I'm going to give you a task. Okay, can you see this video? Can you see a kind of video on the screen?
Yes.
Okay, so I'm going to try to play it slow. And this guy in yellow here is Usain Bolt. Okay, is anything blocking the chat window or something blocking the screen? I don't know. So this person here is Usain Bolt. Okay, so I'm going to run this race. It's going to take a few seconds for it to run, and we're going to count how many steps he's going to take. So will all of you count with me? I'll try to count a little bit loud, okay? And you also keep a count, and then we'll compare what we got. So it's started. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. Okay, I got 41. So now quickly, let me stop this. I think okay, that was quiet. Now it's silent. Good. So now, what numbers did you get?
Yeah, I got 41.
Roughly 41, right? Okay, I got, okay. Anyone else got 41? On chat, you can tell if you got some other number. Some got 44. Okay, good. So it's roughly 41, 42, 43, 40. Okay, so depends how we count. But we can, nice thing, I can take an average of all the numbers. Okay, somebody even got 47. So run it. Okay, you
I
can
got
do this.
38.
Sorry?
I got 38.
38. Okay, so you can do this like an experiment. Okay, how experimenters do is they don't necessarily make one very careful calculation. It's better for us to take 5 times, do this experiment, write down each time the number and just take average. Okay, so anyway, whatever we use, we're
This
going to
video is actually, I think, blocked in India.
Sorry, say
So
that again.
this video is blocked in India.
Oh, I'm so sorry, but you saw it on my
Yeah.
screen.
Yeah.
Yeah, I'm sorry. Yeah, it's blocked in all kinds of strange ways. I don't know why does it say blocked? Where does it say blocked? On the course web page?
Yeah, it says that this
Yeah.
video
It's blocked
Yeah.
in the US also. See here, it's blocked. But if you click on this watch
Okay.
on YouTube, if you click on this link, it will take you to YouTube. That's where I showed it to you. If you go directly to YouTube, you can
Okay.
watch it.
But there's no link in my page.
When you
It's
click on
like
this
only.
thing, right? You just, I think, okay, if there's no link, maybe I can send, the link will be on the Trinket site, I think. I'm not sure. Okay, we'll find a way.
Okay.
Yeah. But we watched it together. And by the way, this whole counting thing will be on our recording also. So you can watch it again. Okay, if you need to count again. But I want to teach you an important idea here that if you want to get this number, you can either count carefully or you can just count approximately 5 times or 10 times and just take an average. Okay. And we will get what we need. So for today, let me use 41. Okay, we can even use 40. It doesn't matter. So the first question is, if you take the, we want to figure out how big is one step, but we know the race is 100 meters. So if he takes 41 steps for the race, then how much time would he need? I mean, how big is one step? And you get an answer. We're going to use our int trick now. So let's just say int here. And then let's look at this. Okay, so it's 2 meters. Okay, because this is 100 meters, so this is 2 meters. So what is that in feet? Someone? About 6 feet, right? Little 2 point, yeah, it's about 6.5 feet. If you actually take off this int and look at it, you'll see it's a little bit bigger. So quickly we can ask this question now. Okay, so it's a trick question, but you see now, okay, so based on this, I should have asked you to calculate, but okay, I calculated for you. So we see that it's about 6 to 8 feet, okay? So that is basically, and here I've given you the answer in meters and feet, okay? So now that you have his stride length, then we can calculate, how much time. Of course, we used the time, so we can go back and forth. But now what is important is you can go back and you can start asking questions like, how many steps is he taking per second? So I'm not going to go into that now, right? But you can easily see I've done some small calculations here. You can easily go and calculate how many steps per second. What does anyone think? So let's guess. What do you think? Does he take 1 step per second?
I would say 2.
Okay, font is too small. Okay, somebody says he takes 2 steps per second. What do the others think?
Yeah, I think 2.
Okay, so you're going to do the calculation for me. Okay, how many steps? You
I
want me
think
to?
number of steps divided by the total time taken. Because like,
What is that?
if it's I think the number of steps, like, because number of steps he'll do divided by the total time, I think.
Okay, yeah, somebody suggested the answer. So actually I have it here, right? He took 41 steps and the time of his race was 9.5 seconds, right? So he took 41 steps in 9.5 seconds. Let's see how many steps per second he took. The answer is like 4 and something. Okay, so he's taking between 4 and 5 steps a second. Steps change in speed because as he accelerates, but on average it seems something like that, which is also kind of pretty interesting. So now we come back to the original question. To run faster, what do we need to do? So I'm saying you should go and try this exercise. Can you do 4 steps per second even if you're running in the same place, right? And it's very hard. How am I going to count it? Right? And I'm showing you all these ideas. When you see something is difficult to measure, one way to do it is you run for 10 seconds, see how many steps you ran, and then divide by 10 and so on. I'm curious to see what you come back with, right? So one thing is taking a lot of steps per second. The other thing is having bigger strides. And so I was very happy when I finished this, because when I was a kid and trying to run fast, everybody said run fast, run fast. Even people were shouting from the audience, run fast, run fast. I didn't know what I have to do. Close my eyes, swing my hands as fast as I can. But that was not helping too much, right? But now I know I have to go and train and try to either improve my stride lengths or number of steps per second. So see, we learned a lot of things about this, and what you can learn is only limited by the questions you ask. Okay, so we will switch from here now to the our next thing. Hope you had fun with it. Let me know, okay? And play with the assignments. You can try to expand the questions I asked you beyond this particular question. And let's focus on topics for today, okay? So topics for today is, to spend some time on doing some art with Python. And in particular, what we're going to do is we're going to understand that, one of the cool things in nature is that nature has lots of geometrical things in it, okay? And geometry of nature is something we study in various shapes and forms, right? So people like Euclid actually sat down and carefully wrote down how to think about geometry, and some of you already done some geometry in school, so we can explore some of these, okay? But today's goal is also to play with a little bit of art, so create some beautiful images for ourselves. And in order to create beautiful images, it turned out that people needed to understand geometry. I won't get into this in detail now. If you let me know, we can discuss in some later session. But people had to understand how to use geometry so that the pictures could be drawn well. In particular, how we perceive depth, what kind of geometry represents 3D images. Everything should not be flat, right? Sometimes we want things to be three-dimensional, like if I'm drawing a landscape or something. How do I arrange objects so that, yes, somebody asked about loops. I'm going to do that right now, okay? So anyway, so mathematics is important. Physics also is important. You have to understand properties of light, color, liquid, solids, movement, so many things just to make art. And then lastly, we'll get into this later. How do humans look at images? How do humans understand images? Okay, so lots of cool topics in here. We don't think that just art is easy. There's a lot of interesting things. And the great artists like Da Vinci and so on, they were also great geometers and physicists. They understood these. So at a point in time, the people who are big artists, Michelangelo, these people knew a lot of math and science. Nowadays, we got specialized and we don't learn all this. Okay, so to get started on our journey, we have a simple thing here. Basically, we're going to use this library called Turtle.
Just a quick comment.
Yeah, sure, please.
Before you start on this section, I would like more kids to participate. Like, if you have questions, don't be shy. If you have any questions, if you're not able to understand, please feel free and ask. And also participate. If the questions, it's for the entire class. There are like a lot of kids who are silent. So I would like to have more participation from the class.
Yes. Thank you for saying that, Manish. And of course, I'm planning next time. I'm going to get all your names. I don't have all your names because your login in different places have different names in it, right? So this one.
Excuse me?
Yeah.
Can we do the counting on the fingers question? Because I was
Yes.
a bit confused.
Yes. I'm going to come to it. Okay. Thank you for reminding me.
Okay.
Okay. And do me one small help. When you ask a question, just for the first few times, at least till I recognize your voice, just tell your name also. Okay. That way I'll get to know you. I don't see all of you, so it's hard for me. But I'm going to get all your names, and next time I'm going to ask specific people. I'm going to put you on the spot and say, Aditya, please tell me the answer to this or whatever. Okay. So I hope you don't mind, but I'm going to try to call on you. But please don't wait for me to call on you, right? We are here to help each other and have some good experiences. There are no bad questions, right? If you ask something, I will try to shape it into something interesting. If it's not clear or whatever, we can work on it. So don't be shy, okay? Interrupt me. Yes.
I was working on this question and my code kept on failing. And that was only because I live in India.
Yeah.
And we spell color differently.
Ah.
I tried the code so many times. I'm like, what's going on here?
Yes. Who is this? Can I get a name?
Shaurya Gupta.
Okay, Shaurya. Okay, so we have two Shauryas in this class. So we're
So I
gonna
had to install like Grammarly and then put English for the US, and then it told me I had an error with color.
yes. So color, yeah. So we get to an important point. One is yes, there are all these differences. We won't get into English as a language today, but we will explore it sometime. But important thing is in programming, Python and programs, they are so particular about how we do things, right? So even if there's a spelling mistake from an Indian point of view, if you put OUR here, it will not work, right? We're gonna, but I don't know what is the best way for us. Let's see what happens when we do this. You see, what is nice here is it actually tells me this. So I want all of us to get used to this idea that when we make mistakes, let us go and look at the errors. We won't panic. Okay, we'll look at the errors. It is hard for us to understand, but it says there's no such thing called color. But that's not enough to know that you have to replace this with color. But maybe that gives you a clue. And I have given you, if you see in my code here, I have given you carefully typed out things. So somewhere our brain has to click and you have to compare what I've given you with what has been typed. Okay, and then you can solve the problem. Going through Grammarly and Google is another option, or asking someone is another option, but it takes time. Okay, so let us try to minimize those detours, but of course they happen, and then of course you try to solve it. I'm glad you solved it, and so on. Okay, thank you for pointing it out too. Okay, so now let's go and look at this. So what do we have to do here? So I'm starting from scratch. So first we have to start with the library, which has all the capabilities that we want. So that library, some of you have already learned this because we did this when we had a previous class. Some of you are new, so I'm just going to start again, no harm reviewing. For those who know it already, just think about it with me, right? So first you have to import the library. I like to write from turtle import start, but just to make your life easy, there are other ways of doing this import, but let's just learn it like this. I put it this way to make your life easy, really. Okay, so from turtle import start brings all of the capabilities of this library or this package into our program. What is the first capability that it brings? It brings this capability. This is like a toy store or a turtle factory, right? Every time you say turtle, it will create a turtle. Okay, so let's use it once. Let's say turtle, and then here you have to give some name. So pick whatever name you want, right? You can pick Ram or Sham or Tina. Yeah.
Question.
Yes.
Is it only that there's a turtle in the library? Is there any other animal, or is it just turtle?
Yeah. So good question. What's the name again?
Nishant.
Nishant. Okay. Yes. I'm trying to learn your names. Okay. I have to recognize your voice and then learn. It'll take me some time. But okay. So what's going on here? It's good question. The thing is, this turtle thing. Why did they pick on turtles, right? And the reason they picked on turtles is because there was a person, his name was Seymour Papert. And he came up with this idea that if you give children a toy that can move around in space and you let them play with it, they're going to move this toy around and learn all kinds of things like math and geometry and so on. And the toy that he made was a robot, and it was shaped in the shape of a turtle. So in honor of Papert, we actually call this turtle. Okay? So there is no other animal here, right?
Can I import more than two things? Like more than two turtles?
We will do this in a minute. Okay, yes, the answer is yes.
Oh.
But yeah, you can fill your screen with turtles if you want. Okay, but let's start with one. We'll do something with two as well. Okay, so what is the important idea here? Turtle is something, and it's nice for us to play with a little animal, right? The real turtle is something that would run on the floor. And actually, we can buy robots now, and you can interact with them in exactly the same program. This program can be connected to a robot, and instead of drawing on the screen, you can make the robot run on the floor. So if you're interested in that, we can do a separate course on robotics, and we can figure out how to do this. Also, we have to buy a robot. Okay. So anyway, so the point is when we learn this, there's some cool things that we can understand right away. What I want you, for those who are more advanced, what I want you to think about is what you're creating is not only a turtle, it is actually like a pen or a drawing object. So all programs any program that does art will actually use some kind of drawing thing, right? And then you move the drawing thing around and it creates a drawing. So, okay, so we got turtle, we gave it a name. Then you get shapes. Now, I don't know why they put the shapes in there, but because it's a turtle, it should look like a turtle. So this actually sets the shape. In fact, you can play around with it.
If I don't give it a name, so can I like use the turtle parentheses thing only?
What,
Wait.
say that if you do this? Well,
If I don't give the name.
Yeah, if you don't give the name, then how can you talk to it? You cannot send it any messages.
Okay.
Right? Like it's like saying if I want to create a number and if I just type 3 like that, if I type 3, then I cannot do anything with this 3, right? It will just sit there. In fact, even so, but we can say x equals 3. Now I can use x, right? And then I can do print x.
Okay.
So yeah, so we are using the labels as we did before, but the point is just like x, you can give it any label, right? So I chose this. It's a funny name to give to a turtle, but one of my students wanted to call it taco, so I still do it. I will change at some point, but you should all pick whatever you want, okay? Then you can set its shape, and now important thing, you can set its color. And for now, there's some interesting, somebody did some little bit of work to translate all these English characters into colors on the screen. And so we're going to use those colors to make our images. Later, I'll show you, we'll do a small session on colors and how computers make colors, right? How does a color show up on the screen? And also, where does color come from in nature? Right, very interesting topic. So those who are interested, let me know. But anyway, I will discuss it at some point. Okay, for now, you can try, you can experiment. Usually, especially kids, they try to break it. They will try mauve or turquoise or something and see if it breaks. Okay, you can experiment. So as soon as we run this code now, it should make a turtle and it set its color to blue. Just to prove to you that it actually works, I can change it to red and it's going to be red. Okay. Now I like to use blue because it's easy to see and so on. So let me go back to blue. And now let's start with something. So my goal here is to introduce some loops and also to create some nice shapes. So let's start with the simplest loop, the simplest shape, right? Let me draw a square. I think it's the easiest thing to do. So in order to draw a square, I need to know what is the size of the square, which is the size of one of its sides. And I'm going to pick a number here. Let me pick 100 for now. We'll see later what is this number doing. Okay. So I got size and now I'm going to draw it. First, I'm going to draw it without loops. So what do I have to do? So if I tell all of you that I can just move this turtle forward. So in order to make it move forward, I have to do taco.forward. Please go forward. And then I have to give it some amount of distance. And so I give it size. So let's see if this works. Sure, it works. And you see, as the turtle moves, it leaves a trail behind, and that could become the side of my square. So now first question for us to figure out, what do I have to do next if I want to make a square?
Turn right or left.
Left 90.
Okay, somebody said right, somebody said left. So I generally, huh?
You have to turn left.
Why left and not right?
Because if you turn right, you'd make the square go down.
Yeah.
And they both work, but
They both work. They both work. Okay, so that's a whole nother discussion. Should we turn right or should we turn left? Actually, when it comes to driving on the street, it really matters. And of course, it's exact opposite between US and India. People drive on the right and people drive on the left. It turns out that when you're driving on the street, certain kinds of turns are easier to make. So since I'm in US right now, I will answer in US terms. In US terms, which turn is easier to make? Is the left turn easier to make or right turn easier to make?
right.
Right turn, right? Because you're not cutting across the other lane. An exact opposite in India, I assume. Okay, it hurts my head now to switch back to India driving. But okay. So anyway, so you pick, but the rule I want to give all of, so it turns out that companies have actually spent time, companies like FedEx, where people drive around a lot, spend time asking, is it better that my drivers turn right or turn left? Right? And then they've come with an idea that if they only turn right or only turn left, it's better in that corresponding country because they don't have to wait for traffic lights and they get free right turns or free left turns. Okay. So anyway, lots of interesting questions, but for us, we are not traveling in traffic. We could easily pick right or left. I just picked left. Okay. So I'm going to say taco.left, but I would suggest it's easier to just pick one type of turn. Okay, always in programming, it's better to use less less differences, right? Then it's easier to debug your code. Because if you ask me now, well, how do you turn? I say I turn left. Not I turn left first and then afterwards I turn right. So very rarely I use the opposite turn. Okay, so taco dot left, and how much should I turn for a square?
100 degrees.
90
90
degrees.
Okay,
100.
some of you
No,
say
it's 100 because the first side was 100, and for 90 to be a square, all the
yes, now we
sides have to be
okay,
equal.
so now we have two numbers. There's a size and there's an angle, right? So we're trying to figure out what is the angle. So after I turn, I still have to go forward, and that will be 100 because the square is of size 100. But how much I have to turn, that's a different thing, right? It's an angle. So what would that be? So a lot of you have said 90. Okay, so we're gonna have to figure out this thing. Yeah, somebody says, oh yeah. So okay, we're gonna have to figure this thing out in a minute. I'll figure it out in a minute. Okay, so we'll say it's 90. I think most of you know, right? Does anybody not know that it's 90? You know, you just don't remember maybe. But can somebody say they don't know? It's okay to not know, because I'm going to change this and make it harder. Okay, I'm going to give you some strange shape and say what's the angle. So you can start thinking about that. How do we know these angles? Okay, and the angles in this thing are going to be strange in a minute. We're going to do it. So okay, so we did this. Now what do I need to do to get the? So let's see. Did it turn? Let's go run it. This is nice, right? You can actually play with it and see it happening. So it has turned, and it has turned by 90 degrees. What do I need to do next?
Move forward 100.
Okay, and then?
Turn left 90.
Okay, so basically it's same two instructions, right?
Yeah.
So let's try those things. Huh? Sorry?
You just have to repeat that.
Yeah, I repeated. Yes, so I repeated it. And I got here. Now what I have to do?
Same thing.
Repeat those steps 2 times.
Okay, 2 times, right? So I'm just going to copy all these 4. And so the first thing I want all of you to feel and understand is we don't need any sophisticated thing. By copy pasting, you will be amazed at what can be created. If you remind me next time, I will show you one of my students. By copy pasting some thousands of lines, they created some crazy, amazing things. Okay, I don't recommend it, and it makes my head hurt. And of course, after you did all this, you have no idea what does all this mean, right? In this simple example, you see it's a square. But already if you draw a hexagon, there's lots of things and you have to start counting and so on. It becomes difficult for us. So that's why, yeah.
Instead of copy pasting this, can you write like with only 2 of these? Can you like write a loop that can keep?
That is our idea. So our whole
We can use the for loop.
Yes.
yeah. So
How
our main
do
idea
you make a circle?
we'll go there. We'll do everything today, hopefully, right? So first, let's figure out how to do loops.
I made a circle. It takes forever to do it.
We'll do it. We'll do it all. Okay, so we'll figure it.
Forward 1, left 1.
Yeah. Let's do it. We'll do it in different ways. Okay. For I in range.
Can't you just loop that 360 times?
Yeah, we'll do it. One sec. Let's do a for loop first. Let's do 4 and then we'll do 360 or 1000 or whatever you want. Okay. So first, the thing about loops is you have to first learn and get used to this idea. You have to say for I in range, and for now learn it as a mantra. Okay. Inside range, you have to put how many times you want to repeat the action. So in our case, how many times you want to repeat the action?
4 times.
So you put 4 here. Okay. That is simple idea. Then you put a colon after this. So this much you have to learn. Okay, we'll come back to this again and again because it's going to be very useful to us. So you just say for I in range 4. Later we'll see why this I is needed. Right now I don't need it. Okay, but we're going to use it in a second. And then you take what is the repeated action, just these 2 steps, right? So I take these 2 steps. I can delete all the rest. And then I take these 2 steps and I tab it in and I get rid of space. Okay, so notice this tab here. You have to hit the tab key and make sure that all the repeated steps are lined up. If I do this, it will be an error. Or if I don't align it, it will be an error. So I'm going to explain why. But before we look at errors and so on, let's just run this thing and see what happens. Okay, that's good for us, right?
Why are some lines darker than the others?
It's some kind of illusion. It shouldn't be, okay? It's probably my screen and the way it's drawing. I've never seen that happen before, so we'll have to play with it and see. Sometimes also when Zoom is actually recording my screen, It distorts
Even in my screen it's dark. Like the other two sides are darker than the first and third side.
Interesting, right? Interesting. There are some ways we can control the width of those lines also, okay? But we won't get that deep on those topics right now. Good observation though. Should not be. Technically, they should be the same. And in the past, I've seen it be the same. So I have to go and figure out why. But something to look at. So now, important question. What is this? Let's think about this again. How do we write a loop? We first decide how many times we want to repeat the action. And then we put that number inside this range. We'll understand range more in a little while in different ways. And then you put a colon after this, and then you.
Excuse me.
Yes, please.
Can you tell what is the use of why do we write for I?
So I actually.
Is that a particular variable?
Yes, I is a variable, and actually, just to show you right now, I'm going to show you what happens if I do this. If I say print I, we can see what is going on. Okay. So let's see what happens. You see, each time it's drawing. Can you see below here? I hope you can see it. You see, I is being printed out. In fact, I can put, like, we can do better than that, right? We can say I equals, this we learned last time. I converted, use stri and print it out. So we can look at it carefully. And you see, first I is set to 0, then I is set to 1, then I is set to 2, then I is set to 3. So I made a comment that I is not needed for this program, right? Because why? Because all the steps are identical. But suppose the step depended on the value of I. For example, first step, I want to make it small. So for example, let's do something mildly silly here, but let's see what happens. If I take the size and I multiply it by I. Then
Quick question.
Yeah, go on. Yes.
So you wrote I. Can you just write any variable you want?
Correct. So you can actually, yes, you can use any variable here, whatever you want to call it. Okay, you can call it J, and then J will work, right? So any variable is fine, right? But I was giving an example where I could take the size and I could multiply it by I. And actually, let me make the size a little smaller so it fits on my screen. See what happens. You'll get some strange looking shape, right? Because first time I multiplied I with 0. So that's why this thing was very small. So 10 is probably too small. Let's make it 50 and see what happens. You see what I mean, right? So this is a very strange shape that I don't need. But you could use the I to make interesting shapes. In fact, it's this kind of shape that doesn't close. In fact, let's see what happens if I try to do this now. Let's do, I don't know, 15 or 20 here. Let's do 20 steps here. Let's make this a little smaller because it's going to get very big. So let's make it 10 and see what happens. You'll get some interesting shape. In fact, it's going to be some kind of square spiral. It's going to get bigger and bigger. Why is it getting bigger and bigger? Because it depends on I, right? The side length is dependent on I, right? So kind of cool, right? So as you play with this, you can create all kinds of amazing things. So I'll call this a square spiral, right? Usually we draw spirals, they're curvy, right? These are not curved, okay? So anyway, that's a detour for us. For now, we don't need the I. Later, I'm going to show you some examples. Like for example, if I want to print out a multiplication table or something, then I can use the I to do some work for me, okay? Sorry, I'm running that again. Okay, so, yeah. Somebody was asking a question?
So my question is that, what is the difference between a colon, what do you call it? Oscillator.
What is an oscillator?
Semicolon and a colon, you mean?
Semicolon?
Yeah,
this one?
Mm-hmm.
No, so in Python, only colons work. And now we should ask the question, why do I have the colon there at all, right? And the answer is I have the colon there because Python needs to know how much has to be repeated. And so how Python knows what has to be repeated is it starts with the colon and then it says everything that's indented by one step that has to be repeated. Okay, and so we're going to find other languages, somebody who knows Java and so on, you might see constructions, not exactly this way, but they will use brackets like this. Okay, and Python people said brackets, they want to make Python look more and more like English. So they want trying to minimize extra symbols. And so what they did is they use a colon and then they got rid of the brackets and then they use indents. Okay, and initially it is a little annoying to pay attention to indents, but those who work with Python get used to it and they have no problem with indents. Okay, so now we are this far. Let me show you one more quick thing. If you want, so this will draw a square. Now I've gone back to my square, and oops, it's too small, so let's make it a little bigger. And now I want to say, suppose I want to fill up the square with something, right? So you can say taco dot, before I start drawing something, I say taco dot begin fill. And then here I can say taco dot end fill. Okay, please remind me before we hang up, which we'll hang up soon. There is a cheat sheet on our on our course website here, which has all these commands in one place. Okay, some of them are for the next class, but it's okay. You can take the cheat sheet and use it as well. Just remind me, show you where to find it. Okay, so now if I run this, let's see what happens. It's going to draw the shape and it's going to fill it, which is kind of cool, right? Okay, now I have to show you a couple more things, and we can draw all kinds of nice
Change
things.
the color of the fill.
So to change the color of the fill, so then you have to change the color of the turtle. So you say taco dot color red, and then it changes. Okay. There
So
are more.
you're saying the square and the lines have to be the same color.
The square and the lines are the same color right now. I don't know. For now, let's keep it that way. Keep it simple. Okay. Next time I'll show you how the boundary can be a different color. But there's also a trick you can do. You can draw two, if you want the boundary to be different color, you can draw two squares of slightly different sizes and put the colors on them. Try to solve the problem that way. What's the difference between single quotation mark and double quotation mark? This is a very important question. We talked about it briefly last time in terms of punctuation, right? So in Python, actually single and double are equivalent as far as making strings are concerned. We have the quotation mark here because red is a string. So you could use single or double. All of these things with single quotation mark, they're all strings. You can use single or double. Okay, so we're getting almost here. Now, I want to show you how to make interesting patterns.
Does this taco.begin fill only work with loops, or can it work with, like if I just write it 4 times, will it still work?
Yeah, it works with any shape, any closed shape. Okay, it's kind of important because it needs to know which region to shade. As long as you have a closed region, it's going to fill it. Then you can try with non-closed regions. Okay, for example, you try this, if you take a 4 and make it 3, okay. By the way, this is a beautiful thing I want to share with all of you. Programs are beautiful because you can try it out. You don't have to ask anyone, right? You get an idea, try it. Okay, you might break your program, but that's okay. You can quickly make it back again, okay? So notice if I do only 3 sides of a square and say fill, I don't know, let's see what happens. Okay, it kind of filled it, right? So it kind of figured out that the next line is there, maybe because it turned and so on. But you can imagine that sometimes if it's not closed, the red color might spread out into some region that you don't want it to spread. So you might create shapes like that. But for now, it seems like for squares at least, it's okay. So then
I tried 2 and it made a triangle.
Say that again?
I tried 2 instead of 3 and it made it right triangle.
Yeah, so it's trying to guess for you. It's very helpful, right? If you try 2, it's kind of some, see it kind of, which is not nice. You should draw a triangle and fill it. Okay. Speaking of triangles,
I think it tries to figure out the least distance between the ending point and starting point.
Yes. So but that least distance can result in a weird shape, right? Because it depends where these 2 points are located. So yes, so it kind of creates a subset of the drawing space, which is by connecting the last 2 together and then filling it. That's a good answer actually. Okay. So we said all this. So now there's one homework assignment for all of you. Try to draw an actual triangle. Okay, this was not an actual triangle, right? So if you do this, so you have to basically figure out angles. So you have 2 things to figure out here. You have to figure out the angles for a triangle, and then you have to figure out the angles for any shape. Let's do that as an assignment, okay? So, okay, that became a square. So what, I have to change the angle. So let me change the angle to something. Does anybody want to guess? If I want to get a triangle, what should be the angle?
120 degrees.
120.
120.
Some of you were with me
120.
last time. I'm sure it's 120. But some of you would say 60. I would have said 60 because of my schoolwork, right?
120.
Yeah, but 60 doesn't work, right?
40?
Huh?
45?
Okay, we can try. So why don't you play with it? You can experiment and find it, and next time we'll discuss, okay? And if you need it in between for some reason, so that's what 45 does. Okay? Even different, okay? So we'll figure out these angles next time, okay? If you figure it out when you do your projects, you can do. But now I want to show you one last thing, and then I'll let you go. And that is how can we make interesting patterns, okay? Actually, I could just, okay, 1 second. Let me just save myself some time. I'll take this code. I'll take our looping code here from here and just put it on the patterns page. I don't know what happens when all of you come back and log in. Do you see all this code here or you don't see it? Does this remain?
Yeah,
or
it
does
is visible. It is
Ah.
visible.
Oh, yeah, I see it.
Oh,
For me, sometimes if I write it on here, it doesn't stay.
so you see here for each, yeah.
It
So
only stays on trinket.
no, I'm saying that my code is going to stay, right? Because I wrote it and you're looking basically at my trinket. For your own work, you have to do this button here. There's a button called save.
Oh.
You have to use this button, okay? And then you
Okay.
save it. But then you cannot see my code. Then there's something here. I think there's a thing called unremix or something. There's another button. You click on that button, you could probably see where I left it. Try it out and let me know, okay?
Okay.
Okay. Yeah. Anyway, this should not be a lot of code and the video recording will have it and so on. So let me show you one last trick and then we can wind up. So I took out the fill. Now I got my little shape and the idea is now, so first of all, there's two things to do here. So let me give you quickly on the trinket site. I want to show all of you. I put some things here. For example, see all these shapes I created for you. You can try to draw all these shapes. I've given all kinds of exercises for you. Now I want to show you this one, right? Something like this. You see that you make beautiful patterns like this, right? So give a lot of exercises. And you can see another one I did, make a house like this, right? And the idea is you have to basically look at what you're trying to do and understand which shapes are used for making that. Then you have to figure out how to write the program to make those shapes. Okay, so there's lots of interesting things for you to try. It doesn't matter if you finish it or you don't finish it. Okay, try as much as you can. Yes.
Can you change the position of the turtle?
Say that again one more time.
Can you change the position of the turtle?
Yes, you can, but I'm going to make
Without
you.
making a line?
Sorry, say that again. Sorry, I interrupted.
Without making a line, can you change the position of the turtle?
Okay.
Yeah, using the pen up and pen down
Yeah.
function.
So there's a special command. There's a special command. Let's do that in 1 second. First, let me show you some patterns, and then I'll show you this pen up and pen down. Okay. So first thing is, in order to do patterns, I can take a shape and try to transform it in some way, right? So for example, to transform it, I will do another loop here, and I'll say for j in range, and let's say I don't know 60. Okay, and then I'm going to still draw my square, but I'm going to rotate it 60 times. How do I rotate the square 60 times? After I draw the first square, I'm going to do a small turn. Okay, and because I want to make it nice and symmetric, I'm going to turn by an angle of 6. You have to figure out why I choose this, okay? But I think you understand. It's 360 divided by 60. So I'll put 6 here, okay? And let's try to run this. Okay, by the way, the turtle moves at some speed. You get to control the speed of the turtle. You can say taco.speed, and 0 is the fastest it can go. It's counterintuitive, okay? I think 0 is the fastest. You can do some research into that if you want. Now let's see what happens if I did this. Oops, I forgot my colon.
Yeah, your colon.
Yeah, I got it now. So let's see what happens. Okay, I got some shape. Why was I? Because my angle was not correct. It was 45. So let me fix my angle to 90 because I was drawing squares. And then let's just draw this again. So you see, you get a nice looking shape, right? It's kind of nice looking pattern.
Whoa.
So I'm going to let it finish, but as it's finishing, how many of you like this pattern?
It's beautiful.
Whoa.
Right?
Yeah, it's nice. If you had to like color in this, would
Yes.
you have to do the taco begin in the starting of the
Yeah.
4J loop?
Yeah, so let's try it. But of course, when you do patterns, if you fill it, if you begin, if it might just blur out everything. You know, the colors will fill up all these nice lines, and the pattern will get smooshed up. Right? Let's see what happens. It's going to fill it at the end, so it'll create something. Let's see. I never tried. So this is the beautiful thing for all of you. You can try anything you want to try, right? You can try all kinds of beautiful things. Okay, let's see. It's going to fill in a second. Whoa. Okay, not what I expected, but it's also interesting in its own way, right? You,
Look at the sun.
yeah, it looks like a peanut butter cup from the top, right? So you can make you can make all kinds of nice patterns. Okay, so I'm going to. Okay, so there was
It
a
looks
pen.
really beautiful. It looks
Yeah.
really beautiful. If you add 2 or 3 colors, I tried last time and it turned out really beautiful.
Okay, so in order to change colors, depending on when you want to change, you can change after each square. You can make all the colors different. You can try. So now the point is this: explore, experiment. Sometimes you can just play with things. All I did here was create small shapes and then transform them. Sometimes you can rotate them. Sometimes you can move them. Right? You can make all kinds of beautiful patterns. And I've given you lot of exercises. Right?
Can
Lot
you
of yes.
can it be on any color? Like, can you say turquoise or something?
Yeah, try. You try it. If it breaks, you let me know which color doesn't work. Okay. Yeah. You just put the color.
I tried it and it became black.
Yeah, if it doesn't, if you
Yeah.
don't spell it correctly, it will become black. For example, instead of red, if I say red like this, then it will say, I don't know what you're talking about. It won't break. It'll just make it black. So if you try some funky thing like turquoise, make sure you spell it correct. Okay.
Okay.
Okay. And later we're going to next class. Remind me. We will talk about briefly when we review this. There's a way to specify colors as numbers, and then we have less chance of spelling mistake and so on. Okay. So play with it. Now I said I'll show you where the cheat sheet is. So let's see if we can find it together. If you go back to the course website, if it's not there, I'll upload it later, but I think it's there. It should be on the right somewhere. Yeah, you see here, there's a Python cheat sheet. I'm just going to click on it. And everything you kind of need is here, or many things you need is here. Okay. Have a look at it. I have another cheat sheet. You know what? Don't worry about this time. When I send you an email, I will update this. I have a better one, which has more commands. It's a little bit more advanced one with less commands that are useful to you. Oh, somebody wants the fingers question. Okay, how are we doing on time? I think I used up all my time, no? I think Suhani is saying something.
Yeah.
So what shall we do? I don't want to hold you. I don't want to tire you guys out. So how about we do the fingers next time? Okay, let's do something, a compromise, right? Let's do the fingers in a simple way. Okay. So does everybody know this finger puzzle?
Yeah.
Yeah.
And what was it?
It was like you take your left hand
Yes.
and you just count
Yes.
the fingers and you keep on counting up and up.
Yes.
Just going side to side.
Yes. And so you go, yeah. So if you do that, then what would happen? So let's see. So, yeah. So the question was, if you count up to 1,000, right? If you count up to 1,000, which finger are you on?
You get the index.
Why? How do you know that?
Because I just did there's an easy way. You could just do 1,000% 8 and that would find the remainder, and
But
that
why should I do %8?
because that would just find the remainder.
I know, but why do I need to divide by 8 and not 10?
Yeah, the thumb would be 8, right?
Yeah.
And
Yeah. So you're getting at the right answer. There's something about 8, but usually fingers are connected with 10, no? We have 10 fingers, 5 times 2, we went up and down twice. So you would normally think it has to do with 10, right? Not 8.
But you're not doubling on the pinky.
yeah.
Somebody's got those are the ideas, right?
Wait,
So
then shouldn't it be 9? Because 1, 2, 3, 4, 5.
No,
6,
because
7,
there's
8,
also
9.
the thumb you're not doubling on.
Right. So those are the correct
Okay.
things. Those are the correct things. So notice I'm less interested in the answer. I'm more interested in how we think about it, right? So there are different things that people will do. There was one of my students actually sat there and counted to 1,000. right, and said that's the answer. They were very patient, obviously, right? I don't know how many of you will sit there and count up to 1,000. So one thing to do is to sit and count 1,000. The other thing is some of you have done it. You try to look for pattern, right? And you can even explore some small numbers, okay? So one thing you can do with Python is how do we make Python count up to 1,000? So we can say for I in range 1,000, right? Let's see what happens.
You know,
Oh,
could
font
you
is,
make the font louder?
yeah,
Like
yeah,
bigger?
I'm going to. I wish it would just do it automatically, but okay. Okay, for I in range 1,000, print I, right? And you see, the beautiful thing I tell people about programs are they don't get tired and they don't make mistakes. They don't get bored also, right? Humans are not like this. We get tired, bored, frustrated, all kinds of things. For I in range, so you can print I, right? And boom, it will go and print out something if I did it right. What did I do for? Oops. I don't know why my screen is hanging for some reason. I'm just going to reload it. Let me see. By the way, if it crashes, sometimes you can just fix the problem by just reloading. Okay, it should not happen
I
to
think it should not be indented towards the right.
Yeah,
It
let's
should
see.
be.
As soon as I get my screen back. Whoa. Something is going on which is not good.
Yeah, there's no place to code on this.
There's no place to go. It's gone. Okay, let's go find another place. Okay, I don't know. Let me put it somewhere. Okay.
I think
Yeah.
there's some on the session one. There's counting on your fingers
Yeah, exactly. Somewhere
on
here.
the heart.
Yeah. Let me find it. Counting on your fingers. There you go. Under heart. Okay, so yeah. So I say show trinket. And then here we can say for I in. Oh, again I gotta make it bigger. Let's try not to break it this time. For I in range. Okay, so we'll go gingerly. Oops. For I in range 10 colon. Let's get it right. Sometimes big numbers, if you make a mistake, it's going to spin, right, and break. So okay, for I in range, okay, you see it prints, but it starts from 0. Does Tina start from 0 or 1?
1.
So if you want to start from 1, not 0, Python always starts from 0.
1, 10.
1, 10, right? So we got this. So I can go from 1 to 10. Now, how do we get it to use different fingers, right? So let me show you the simplest way to do it. Next time I'll show you a clever way to do it, okay? So you can just check it, right? So we can say so now I'm teaching you a new thing. It's how to check something. You check if I is equal to, first let's say if I is equal to 1, right? If I is equal to 1.
Wait, but why are you doing a comparison? Oh, right, you're comparing I.
Yeah. I'm going to print I, right? I'm going to print I, and then I'm going to print which finger is I on, according to our rules. I is on the thumb, right? So I'm going to print I, and then I'm going to print thumb. Is everyone okay with this? Let's see what happens.
Why did you do the equal to sign twice?
That is...
That's comparison.
That is for comparison.
That's
so you can
comparison
use
operator.
Or less than or greater than. We'll come to comparisons next time, okay? So equal to 1, we'll check if it's 1. So let's see what happens if I did this. It will say 1 and it will say thumb, right? So that's easy. So it said 1 and thumb, and then if it's not 1, it doesn't print anything. So I got only 1. So now how do I get the next one? So then I say else, and actually in Python it's elif, okay? Then here I say I equals to, what should I print? Just copy this. What would be the next one?
Elif I equals
2, what is it, the next one? What is the answer?
3.
If it's 2, it is?
Index.
Right? And I'm going to leave it as homework for all of you. You can fill up this whole table, right? So this will now say, okay, 2 is on the index finger. But now the question is, when is the next time thumb will come? Which number can we try after? So you look at this pattern here. Which number will come back to thumb?
6.
Huh?
9.
9.
9.
Is it 9 or is it 8?
8.
8.
9.
I'm
Wait.
9.
It should be 9 because the index is not mentioned after the middle finger.
Okay, I missed it, right? So then should be 8. 8? 9. Okay.
It should be 9.
So if I is 1 or I is 9. Okay. Now I want all of you, let's not do it today because I think some of you may be tired. But okay. Okay, so what are these numbers? 1, 9. What is the next one? Can somebody quickly tell me what is the next one?
3.
Huh?
3.
Plus 8.
Plus 8. 9 plus 8. So each time, so basically if I take I and if I divide it by 8, right? These numbers like 1 and 9, if I divide by 8, I'll tell you why I put a double slash there in 1 second. So I will say this has to be equal to 1. Let's see what happens if I run this. You see it found that one. You see here? It found some other things too. Okay. So we have to now play with this a little bit more, right? But I want to pause here because you can see we're getting into some complicated things. We have to figure out what is this, what is it I should check for? When does it end up on the thumb? So how do we figure this out? Can I ask you guys to think about it? What is the condition when it ends up on a thumb? So you have to basically write down some numbers and then, so somebody wanted to use also percent. So let's see what is double, so let's do %8. So what does double slash or percent do? That this computes the remainder. Okay, so let's try this. Okay, so that looks better. So what is I %8? So let's print that out as well. Oh, let's think about it. Okay, so let's take this out. So see, I'm not trying to rush to the answer. I'm trying to be like you. And I'm saying we just explore, right? So what is
How do you make the whole thing hashtag? Like,
you highlight the whole thing. You highlight the whole thing like this and you hit Control/. It toggles, right? Control/ will put the hashes or remove them. So whichever region you want to hide, you just use the Control/. Okay. So if I do 9%8, then let's see what happens. Right? If you don't know something, you can just try it, is what I'm trying to show you, right? The goal is not for me to present, to suggest to you that I have memorized all this stuff. Actually, maybe some things I remember, but more often I explore, right? And that's a better way to do things than I have to keep everything memorized, okay? So 9%8 gives me 1, I'm not sure, okay, so it looks like remainder. 9 divided by 8 is giving me the remainder. What about //? What does it do? Let's see what happens. It also gives me 1. Okay, so something is happening here. Let's now try another number. Let's try, what's the next thing that should give a remainder of 1 with 8 after 9? What is the next number which gives remainder 1? Anyone?
17.
Okay, let's try 17. If you divide by 8, 16, then the remainder is 1 and the answer is 1, right? So 7, so let's put them all side by side. 9%8. So you run this and you see this all giving 1, right? And what we are saying is, this is what some of us in the class were saying earlier, right? Some of you were saying earlier, there's something about 8 that is interesting. This pattern is repeating in 8s, right? So if you keep on trying bigger and bigger numbers, you can start to see. So what did I do here? So let's look at my code now, and then I will ask all of you to finish it. For I in range 1 to 10, if the remainder is 1, right? If the remainder is 1. So I did 1 to 10. Let's do 1 to 20 now. So if it goes from 1 to 20, if the remainder is 1, it's going to say thumb. If the remainder is 2, it's going to say index. So it says thumb, index, and so on, right? You're going to check if these are the right ones, okay? Or if I made a bug somewhere, okay? And eventually, you can just change this to 1,000 or 2,000 and see what happens, right? And that will be your answer. Does that make sense? So what are we doing? We're looking for patterns, and then we're
why did he put a colon after if I %8 comparison 1?
here,
Yeah.
on line 2, right?
Yeah.
The idea is that when I introduced you quickly to this notion of an if statement, we will discuss if in more detail, like loops. Next time I'll review both. So the if is a logical check. And whenever you do a logical check, I put a colon just like the for loop and I indent something. It means that I can tell Python do a lot of instructions if some condition is met. Does that make sense? We're going to write a few programs next time to explore the if condition. So all of them, just like the for loop, all of them have to be repeated. So for example, as I told you before, in the for loop, all these things will get checked every time I change it because all of them are one indent. Does it make sense? So we're going to see the same pattern of using colons and indents to manage multiple instructions. Make sense? So for example, I'm going to put another instruction here, print checked, right? And now it's going to do two instructions if I is equal to 8. So every time I is equal to 8, it's going to print. I don't know why. Ah, there you go. Okay, because it went up to 1000, so it slowed down, right? So let's make a smaller number. I don't think we need to go that far. Let's do 10 or 20. Yeah. And then just, okay. You see each time it did multiple instructions. So we'll explore the if statement in.
Why does it print checked? Oh, sorry. I
pushed
didn't catch
one.
it.
Okay, good question.
Yeah.
You didn't expect me to put that thing in there. So I did, right? Just to show you that if there are multiple instructions, all of them will get executed if I is equal to, if the remainder is 1. So, okay, let's recap quickly what all new ideas we got. First, we got this idea of using.
Wait, so if you write print I plus an 8 equals to 1, and then wait, so you just keep on you'll just keep on doing that till the end of the pinky finger?
Yeah, so for example, suppose we had to do up to 100, right? You want to see where does 100 end up. You could easily run this program like this, right? And you see 97 is on the thumb. Okay, there might be some small bug in my code, which we have to look at carefully, okay? But then you can see if 97 is on the thumb, what's the next number? 98 is on the index finger, right? And then 100 is on the middle finger. So you can find the answer this way, right? So our goal, once we clean up the program and get it right, is to go all the way up to 1000 and we could be done. Make sense?
Yeah, so I is basically like till 1000. Okay, we have to just
anything you want.
Okay,
Now,
if you write 1, 1000, it means 2000, right?
Say that again, what?
If I write 1, 100, it means still 100. And if I write 1, 1000, it means that it's still 1000, right?
Yes, yes. It actually,
okay.
to be precise, it does 1 less than the final number. Okay, so if I wanted to go all the way up to 100, I must really do 101. Okay?
Okay.
We can look at it with a smaller number like 11. Let's see. So then it will be easier for us to see. If you print up to 11, you will see that, okay, I should take off all these if statements. Let's just make print I so we can see what does it print. Let's see what it does. It's going to print thumb anyway 11 times. But you see, now I got it to go all the way up to 10, but I had to take the loop up to 11. It does 1 less than the last value. Okay, so if you put...
What, in the end, why did it write 1, 1?
Because here we were still doing this. So,
okay, yeah. Sorry, I didn't notice that.
No, it's okay. No, good question, good comment. But yeah, that's the whole idea, right? We are not looking here for perfection. We are looking for trying things, finding things, asking all those questions, finding answers to all those questions. And that's how we explore, right? It's like, oh, there's an extra statement there. Let's take it out. And the amazing thing about programming is there are no unexplained things. Even if it looks like there's no explanation, there is always some explanation. We just have to be calm and patient and figure it out. Okay, so let me just recap something for all of you. The use of the for loop, I would like you to learn. The use of the if statement, we can review again a few times. Okay, don't worry about it. Use the loops. This time, if you learn how to use loops and make nice pictures and so on, it's fine. Why did I put this counting on the fingers puzzle? For those who are a little advanced, probably you can do it. But more importantly, I put it because this is a numerical pattern, right? Even counting on the fingers creates a pattern. And the question was, can we find the pattern? And we explored today that there are different ways of finding the pattern. One way is just counting on your hand and trying to see if you can find the pattern. But now that we are programmers, I'm trying to show you that we can have the program print out something that allows us to see the pattern. And we haven't fully done that yet. Next time I'm going to pick up on this and we're going to do some more of these interesting patterns and puzzle questions. Would that be fun? Someone?
Yes.
Yes. Okay.
Wait, I just had one last question.
Sure,
When
please.
I write, if I write 1, 11, it's 1 to 11, right? If I
Yes.
write 2, 11, it's 2 to 11.
2
So
to
it
11.
start from 2. Okay,
Correct.
thanks.
Correct. So this is the starting value. The first number is the starting value, and the second number is 1 more than the stopping value. Okay?
I'm kind of confused. Why can't you?
Yes. Confusion is good. Tell me what's confused.
1,008.
Sorry, you broke up. Can you say that again one more time?
You do 1,000% 8,
Uh-huh.
and then there's no remainder. The remainder would be 0.
Yes.
And if you take your left hand, if you start from index as 0, you get 0, then your thumb is 1, which makes sense, and then your index is 2 again, which follows a pattern.
Yes.
So why can't you just do 1,000% 8 already, and then you're done with the?
No. I'm saying right now, based on our conversation so far, I've left it a little bit as a puzzle for all of you. I've not given you the answer. There's some clue here that 8 is interesting, and there's some clue here that 1,000% 8 may give us an answer.
Okay.
We are not done. Right?
Okay.
It's supposed to make your head hurt and leave you confused. Right? I'm sorry, but it's little bit confusion is good, right? It prompts us to go figure it out. What is this? Yeah. So I didn't choose the option of giving you the answer, right? Okay. So play with your fingers. So the clues are correct. 8 is somewhere here. And I'm saying I asked a question in the beginning. Why 8 and not 10? That is an interesting one. Okay. So you can try or you can ignore 8 and see, can I find a pattern? What is the pattern? When do I return? Do the fingers occur in some pattern, right? So count on your hands with a small number like 15 or 16 up to that. Even write it down on a paper, right? Then you will start to see a pattern. So maybe in the beginning, that's the best way, right? Once we become clever programmers, we won't even have to write on the paper. Right now, you have the trouble of learning to program and spotting patterns. It's a little too much, maybe, right? So let the advanced guys write those programs. You just take a paper and just figure it out. Then we'll come back and write the program. Okay, next time we're going to write this properly. When I started to write it, I realized we didn't spend time discussing if statements. So then let's defer it. Okay, anyway, my plan was to defer it. And next time I'm thinking that we could do some more of these kind of challenging mathematical / numerical puzzles. But let's see, let me look at your submissions. I'm looking forward to see all the patterns and images you create. I just want to leave you with one important thing. Patterns are one type of art, and then images are another type of art, right? So if you want to create interesting images like this is something I did because one of my students asked me, can you make like a skyline, right?
Is that New York City or?
Kind of, right? It could be Bombay too. I don't know. Some place with skyscrapers, right? I didn't put explicitly Empire State Building and so on. If you do New York City, I have to do at least some of the landmarks. Okay? But the idea is when you see important images like this, you have to start thinking, how does it work? Like I've done all kinds of clever things, right? Like the windows are all scattered here and there. So lots of things to think about. Don't worry, whenever you see any image, you start off, you may not finish it. Like, look, this is a simpler one that one of my students did. But see, that fence is kind of tricky, right? How do you do all this, so many things, right? How do you make the turtle move on all these shapes? So there's lots of cool things. So take small steps. Don't get intimidated by big and complicated images or patterns. Just do small things, okay? And then slowly you can build up. Have fun with it. But I think I've kept you all a long time. You as always, you are all so great. Next time I'm going to get a paper and write down all your names, and I'm going to start asking each of you to speak up a bit more.
Yeah, it was very interesting.
Huh? Sorry?
It was very interesting.
Which one? The class, you mean? Or this pattern?
Both.
Okay. So last thing I will say, because somebody said the pattern is interesting. our brains are wired to recognize patterns, right? And we get pleasures from recognizing patterns. So we see patterns in music, we see patterns in art, and whenever we see a piece of music or art or whatever, some of these things, even mathematics, we get pleasure out of it because we start to appreciate those patterns. And as you become stronger and stronger, you start to see more and more patterns and you enjoy it more and more. And now you can even understand how the pattern is created, right? So start thinking about those ideas. Where are patterns in music, for example, right? And so on. Okay, we'll explore all these things little by little. But now I have to let you go and we'll talk again soon. I look forward to working with you next week. And I do go, just so you can see it, I'll show it to you. I do go and look at all your submissions. So I go through this and then I painfully read all of your code. Painfully, I say because there's a lot of it. I read all of your code and I try to give you back comments. Huh? Okay. Yeah, no problem. So I'm going to let all of you go and I'll see you next week. Okay. If you need anything in the meantime, work on these assignments. Try to do one a day or a little bit like that or more. And send me email with questions if you have any questions in the meantime. Otherwise, I'll see you all next week.
Thank you for the
Thank
class.
you.
Thank you.
Talk
Thank
soon.
you.
Bye.
Thank you.
Thank
You're
you.
welcome. Bye.
Thank you.
You're welcome. See you next week. Bye.
Yep, bye.
Bye.